All right, guys, thank you so much for coming to this class to talk about first-time completes using PSC, using ECM to replace PSC. I do up on the screen right now have what we call our motor minute registry. The gentleman in back, Chris Mohali, he actually does a motor minute twice a month. And if you want to learn something new about motors and get a tech tip, some of the tech tips are as simple as why is there a flat side on the shaft? And you'd be surprised at how many people need to know that. And then as complicated as how to diagnose an ECM motor. So if you scan that QR code, it's going to get you enrolled in our motor minute and get you some education each month. Also, what I'm in charge of for Regal, I'm in charge of contractor engagement. So I have a team that works for me, and in that team that works for me, I have Macy Dunn sitting in back. And what contractor engagement basically means is we have a group of individuals that work for Regal that go out and visit contractors, talk to them about ECM motors and why you should stock them on your vehicle, how you're going to make more money by doing that. And some of the training things that I threw on the board right here is just us out there live training to the point where we will help you and guide you through installing your first outdoor fan motor, guide you through helping you install your first variable speed, make sure you're up to date and configure those things out. We cover all 50 states and Canada. I know that's not necessarily part of the United States, but I get to go up to Canada when the request is there. And we're talking about expanding out down into Mexico also. But what Ed up here wants to tell you is today the reason we're gonna talk about first-time completes is one of the things that contractors miss a bunch is the fact that every time they send a truck out on the road, it needs to be profitable, right? So you go out to Mrs. Jones's house and you show up there for a service call, and if you can't complete that call the first time you're there, you're losing money. Who in the room understands that factor or has lived that in the past? So I used to work for a company that was very heavily on KPIs, key performance indicators. And the company that I worked for, we tried to average our guys out with only 4 calls per day. That's all we wanted them to run. And we needed those 4 calls that they ran to be profitable, right? And how much did we focus on for average ticket? Every ticket should generate at least $350 per average ticket, right? Is that a lot of money for a service call? No, it's not much. But what happens, though, is if we don't have the billable hours and we're not averaging $350 per ticket, and we're running way too many service calls that we're not collecting on, that number starts to dwindle down, right? You can very quickly go from an average ticket of $350 down to an average ticket or an average hourly below $100 an hour. Does anybody in this room make money if you're only billing out at $100 an hour? Nobody, right? Maybe, right? There was a maybe. You got to be really lean and efficient at what you do if you're doing that. You have to have basically no $0 tickets. You basically have to have plus north of 90% complete. And then you have to have almost no callbacks to be able to be efficient at that. Because if not, labor is going to eat you up. So we sell motors, right? And we sell motors. So I'm going to focus primarily on stocking motors on your vehicle. But when I transitioned over from the contractor side to the manufacturer's side, when I would go into a wholesaler, I was always surprised at how many times a technician would come into that wholesale house to pick up any part, right? My technicians that used to work for me, they were in trouble, right? We would have talks about going to the parts house to go pick up a part because I can't complete a call because I'm driving to the parts house. And spend half my day driving to the parts house to pick a part, and I end up only doing 2 calls that day because I spent 4 hours doing calls, and I spent 4 hours in the truck or eating a donut or getting a cup of coffee or whatnot, and it becomes not profitable. So we have to kind of figure out the mix. Stocking no parts on the truck, right? Or stocking some parts on the truck. In this case, talking about stocking some motors on the vehicle. Or in this scenario, where they stock the whole warehouse in the truck. I see a shaking of the head back there. No, don't want to do that, right? Why don't you want to do that? You don't want to do that because you start killing your vehicle, right? You have so much spent up in money on that truck where it's going to cost you more to have every part on there. But what we want is to be able to have the parts on the vehicle that are going to be universal and be usable on more calls, right? And the ECM motors that we're going to talk about that to replace PSC, you're getting to the point where you can stock only 1 or 2 or 3 motors on your truck to be able to replace all the PSC motors and to be able to replace the ECM motors that are in your vehicle too, okay? And just to put a little math behind it, if you were to look at a 75% complete ratio, so if you were to look at, you ran 4 service calls in a day, right? And of those 4 service calls you ran in a day, 3 of them you got done, and the 4th one you had to come back the next day, right? So if I had to come back the next day for the next call, I end up changing what my billable hours are. I'm not billing out at 100%, right? I'm not billing out at 40 hours. I'm billing out at 30 hours. I'm only running 15 tickets versus running 20 tickets. And in a week, that's a change of about $2,000 in revenue generated by not billing out those other 25%. Does that make sense? Okay. So if you expand that over a whole year, it ends up being about $91,000 difference in revenue generation by having to go back on a call. And that's just going back on 1 call a day. So I sat inside these wholesale houses and I see a guy come into the building 3 times that day, right? So he had to go get a part on every service call he ran, and instead of running 4 calls that day, 4 profit calls that day, he probably ended up running 7 calls that day to be able to be profitable and make money for the calls he ran. And if you take into account how many more hours per year you have to work to make the same amount of money, and you take into the time and a half you have to pay out to make that same type of money, you go from $175 an hour, and at 75, $131 an hour that you're generating, to down to $115 an hour that the company is generating to make the same amount of money that we would have made if we actually just got it done the first time. It doesn't just apply to motors, right? It doesn't just apply to motors. It applies to every part you put on that vehicle or don't put on that vehicle. So you should evaluate your stock, right? Obviously evaluate your stock and how that works. You should evaluate if you're not turning things over to make sure that your stock is actually working for you, okay? So first example of it for motors. We now make a condenser fan motor that's an ECM that covers all of these. When I first started running service back 30 years ago now, all of our motors actually were directional, right? It spun clockwise or spun counterclockwise. They came in straight horsepowers. They didn't come in multi-horsepower. But now we have a motor that doesn't only replace the downshafts, the upshafts, and all those different RPMs. We have one motor called an Evergreen OM that you can put one motor on that truck and replace 40 applications from one motor. And I like the phones coming up because that means that might be something good. Yes, sir.
Could there be problems replacing a OEM motor with an aftermarket motor instead of using the original?
Man, I do love you, by the way. This is a fantastic thing. The other day you asked me a question. I didn't get your name. Sorry about that. What was your name? What's that? Atlee. Atlee asked the question, is there any issues with replacing a OEM motor with an aftermarket motor in the space? If you replace it with the proper motor, and you replace it with the proper motor in the aftermarket, the answer is no. Could you have an issue if someone took a motor off of a piece of equipment and replaced it with any old motor on the truck and it being an issue with a problem? Sure. But like for like, same type of horsepower to same type of horsepower, RPM to RPM, it's going to work and you're not going to have any issues. Very good question. Thank you. This motor specifically it covers a third horsepower all the way down to a tenth. In one motor, it covers 825 and 1075 in one motor, right? So think about that. How many times you run out and do a service call that is in a third through a tenth on a residential piece of equipment, and how many times you go out and run a service call that it doesn't fall between 825 and 1075? Oh, very little, right? Almost none. So how does it do that? We have two different types of ECM replacements. We have ECM replacements that replace variable speed motors and constant torque motors, so ECM to ECM. And we also have motors that we're going to talk about today that replace PSC, designed as an upgrade, right? Upgrade from what's there, or to make your life easier by getting the job done the first time. So the first one we're going to talk about is the Evergreen OM down here. And that Evergreen OM comes in a couple different styles. The first when we first came out with it, it has the module attached. We call that 6303. Problem with the module attached with that version is you can't flip it upside down, right? When you flip it upside down, the module's like a bucket. And what are buckets designed to catch? Water or stuff, right? So when you flip that motor upside down, it becomes a bucket, and it lasts till the first rain. And here in Florida, which it didn't happen yesterday, but that would be like 3 o'clock in most cases. At 3 o'clock it rains, and you would kill it the first day. And also it was longer. The motor was longer. And in the 10th horsepower and 8th horsepower, it became a fitment issue. So we ended up taking the module off. And when we take the module off, the motor shrunk down to 4.33 inches, and they're going to beat me up on that, but I think it's something like that. 4 inches plus on the size of it. So it fits in almost every application that you're going to run into that fall from a third to a tenth. It has a 2-year warranty. It's energy savings. And the motor is very quiet compared to a PSC. One of the things we don't talk about all the time is when a PSC motor comes on an outdoor unit, it comes on at the exact same time the compressor comes on. So you have like a bang bang and all this noise when the unit starts. This motor starts and it takes 30 seconds to come up to speed. So you may have compressor noise, but you won't have the secondary noise of that motor trying to go from 0 to 1075 in 1 second. Okay? So we tried to make it as universal as we possibly could. So the motor actually has train mounting holes on it. It has ream mounting side screws. Down here. And the module is mounted remote. Right? The module is mounted remote because it's off the motor now. And you're going to mount that on the backside of what I call the corner pillar. I'm blocking the mic. Backside of the corner pillar. So the backside of the corner pillar, there it goes. So this is a new term I never heard. So if you're looking at the contactor, right, and where that piece of sheet metal sits, on the backside of that corner pillar is inside the unit. So mounted inside the unit, we're going to mount the module there. So the next question that usually pops up, is it water resistant? Yes, it's outside in the air, so it's water resistant for moisture. So what we want to look at is the wiring for it. We made this as basic and as simple as possible for wiring. You have 3 wires that you're going to hook up and a ground. So the ground, obviously, run that all the way through. You guys used to on a PSC motor, usually just break that off and throw it away. We are not going to do that on this motor. We're going to hook that ground up. We're also going to hook up the white wire and the black wire on a straight cool system to T1, T2, right? So load side of the contactor. We're also going to pick what RPM we use. We have an orange wire for 825. We have a yellow wire for 1075. And we're going to select that RPM from whatever you pulled out. So if you pulled out a 1075, I'm going to take this yellow wire and I'm going to connect it to the piggyback. If you took out an 825, I'm going to take the orange wire and put that wire to the back side of the piggyback. And then when the power comes on, when the contactor closes, the motors are going to come up to the speed you told it to run. And if you had a really big blade, it's going to use more power or more wattage to get to 1075. And if you had a smaller blade, it's going to take less wattage to get to 1075. Yes, sir?
I was going to ask, with your horsepower, do you want to have a motor that might have more horsepower because could it be too strong for the application? put too much load on some of the stuff. So how would you know what horsepower it was if you had to replace this motor afterwards? You wouldn't actually know what it should be.
Okay. What's that? Good question. So the question is, do you ever want to, I'm gonna paraphrase your question. Do you ever want to up the horsepower on a replacement of a motor? Would that cause any detriment? Would that have any issue? No. You would want to come back with as close to the same horsepower as you had before. On a PSC to PSC replacement, we match the amp draw within 10%. So if you had a 1 amp motor and you needed to replace it, you would replace it within 10% of that 1 amp. If you are going from a PSC or standard motor to an ECM like this, it auto sizes itself to the blade that's on that system. And the blade that's on that system, the fan blade that's on that system, was designed inside that system, and they selected the horsepower of that motor from the blade and the CFM that they needed to produce. So by putting this new motor in there and putting the old blade back on top of it, it's going to draw the same wattage or the same horsepower as the old motor did, and you're going to size it the right size. Great question. Y'all need to listen and pay attention up here. It's impressive. All right, thank you. Good stuff. So that's for a straight cool. That's for a straight cool system on a heat pump, which I imagine here and most of you guys now do some heat pump stuff, especially in Florida. I live in Arizona. On a heat pump, the only change we make is we move the speed wire, the RPM wire, from the piggyback over here directly to the defrost control. Because what really turns this motor on and off is the speed wire, telling it to run what speed we want it to run as. So we would move that wire over to the defrost control, the output terminal of the defrost control. Typically, if you were taking out a condenser fan motor that was a PSC, that typical wire that was going there would be a black wire that was landed on there that you're gonna pull off, and then put your speed wire there. The color of the wire doesn't matter. It's whatever color wire they put to the output terminal of the defrost control, but I would pull that out. Yes, sir.
Does that mean, so if the orange and yellow wire are what starts the fan and selects the speed, if you have constant power at white and black, L1, L2, you're not gonna get it.
It won't turn on. So if all you did was give it power to the module and it wasn't getting a signal to come on, it won't come on. Actually, in earlier drawings, we actually had the horsepower, we had the power wires going to the incoming power, the line side, and then had the speed wire going to the other side. But to simplify it, we on the straight AC, we put it to the load side of it. Yeah.
So these contactors that just have one leg switched, the other leg is just straight through.
Yeah.
I want to make sure that the orange or yellow is attached to the side that switches.
It sees a difference in polarity, right? You would want your speed wire and your black wire on one side. You would want your white wire on the opposite side. And when you have a single pole contactor, obviously everything becomes the same polarity until that contactor pulls in, and then it sees a difference in polarity, so it wouldn't come on. Other questions there?
This is just utterly curiosity, not saying it has a real life application.
Uh-huh.
Can you switch back and forth between orange and yellow to get a 2-speed motor?
Yes.
What happens if you power both?
Doesn't come on.
Okay, so you have to pick one or the other.
So if you took out a 2-speed condenser fan motor that was PSC and it had a relay in it that separated the 2 speeds, you could put these 2 wires to that relay and you could switch between the 2 different speeds. So like in my market, a Train package unit that had a 2-speed, you could put it in that application. Now, is the RPM going to exactly match that with what was in there before? I don't know. It depends on what was there, but you would get 2 speeds out of it. But if you power up both speeds at the same time, the module knows that the technician doesn't know what he's doing and doesn't come on. It says, nope, I'm not going to come on, right? So, but yeah, great question. You can use it as a 2-speed, but most applications single speed, right? Any other questions? No? Yes, you do. I knew you do. You're having a conversation with your mom right there.
I'm doing research. I'm doing research. Hold on.
Google's no fair. I don't have Google in here.
Must need to validate it.
Okay.
I do have a quick question. Yesterday in the other guy's class talking about these, he was mentioning of leaving the ECMs powered up all the time due to the discharge and whatnot of the 4,000 microfarad capacitors in there. Will that not eat up contactors?
The short and easy answer on this one, this motor is designed to be able to turn the power on and off to it, and the micros in it operate fast enough to where it's not an issue. It is not as good an answer as Chris Mahaly would give you right now, but that is my answer I'm sticking with. Okay, all right, we're moving on while he's looking. So, application, the back side of the corner pillar. All right, so in this scenario here, we have I don't know what brand that piece of equipment is. I probably shouldn't say it anyway. This is what I call the back side of the corner pillar. Our instructional designer that made this picture decided they wanted to eat up fan blades. That is not the place you would put the module because that blade would come in contact with the module. But in the real world, we would move it down a little bit to where it's away from the fan blade, mount it on here, avoiding the header, and it mounts in that scenario. Obviously here we mount the motor in the downshaft. Make sure you take the drain plug out on the bottom, right? And then you're probably in the back of your head, we said we had train holes in it before. We can mount on a train, but what is the obstacle on a train system with a wraparound coil? Well, there's no backside of the corner pillar. So in that case, this motor comes with a 90-degree bend. You actually have to bend it yourself on this chunk of sheet metal, and it mounts to the side of the corner pillar at that point in time, right? It mounts to the side of the corner pillar. And the funny thing is Train actually put a hole through the cabinet right here that you can run the wires right through, hook it up to the contactor. That door closes perfectly over the top to where you're not going to crush anything. And we have our connection sitting inside, hooked up to the contactor, and we have our tether hooked up down here. Okay, yes, sir.
We have that on a straight cool system. On a heat pump, I don't know if it's going to fit.
Heat pump.
Right there.
Yeah, wedged it in there. So on a heat pump, it fits between the dryer and the reversing valve. We get some pushback on the module. You know, it won't fit here, won't fit there. This has been 4 years that we've had this out here, and when I go out and do classes for people, I put a jokingly bet out there that if you find one, give me a call, and if within 5 minutes we can't figure it out, I'll admit you're wrong, right? Or I'll admit I'm wrong. But it takes a little bit of thinking through it. We're technicians. We're not sitting in a factory pushing a button or pulling a switch. If you can look at it and have a little bit of imagination, you can figure where it goes. And usually it's under 5 minutes extra to install this. But 5 minutes comparing to going back and forth to the parts house is easy peasy, right? Last piece of this. It auto-sizes itself, and I hit it before. Auto-sizing itself because you're telling it how fast it wants to run, right? So if you took out a 1075, you took out 825, you've told the motor how fast it needs to spin. The only thing the module has to do now is give it enough power to get there. So it auto-sizes itself because of the blade or the resistance you put inside the system. So if you put a little bitty blade in it, it's only going to run at 60% output. You put a really big blade in it, it might run at 90% output, but it's going to adjust from the blade. There.
So when those blades are covered with ice and snow, will it give it a little more horsepower, fling that stuff off of there?
It's going to adjust to the amount of power it needs to spin that at 1075.
It's not a once and done. Well, it will
monitors.
Work.
Yep.
That was the same question.
I like it. Side by side. Yeah, not supporting that one, but it will adjust for the load. What's the cost? Ask your local wholesaler. Is the cost? Oh, I thought you asked that. Sorry. Ask your local wholesaler on what the cost is. Yeah, the cost is typically about 50% more than a PSC. All right. So if you do the math on that, and you're stocking five PSC motors to replace condenser fan motor, if you're 50% more on one, and you can charge for that 50% more, and you don't have to go back and forth to the parts house, you kind of solve the case, right? Solve the case. Yes, sir. Uh-oh.
Okay. So if I believe I understand how this works, which I might not completely, for the heat pump, if when you're supposed to piggyback it onto that contactor, but if it's a heat pump system and you were to instead of putting it on the contactor, you put it on the other thing that you
The defrost relay output, yep.
defrost relay, when it's in regular AC mode, would it still work because now that color wire is no longer on the main contactor?
So the wiring or the defrost cycle, right? The defrost, how defrost works on a heat pump. So when you are in cooling mode or you're in heating mode, that defrost relay is closed, right? Allowing the fan to have energy going to that. When you go into defrost, three things happen. One, you switch the reversing valve. Two, you energize the auxiliary heat scenario going into either the dual fuel or the air handler or whatever you're dealing with. And the last one you do, or they're all simultaneously, is you open up that normally closed relay. When you open that normally closed relay and you lose power to that colored wire, 1075 or 825, you take that away and then the fan shuts off. When you what we call terminate defrost, when you end defrost and the coil's melted, better word for it, defrosted, melted, when you end that, then you remake that connection, and the other three things go in the opposite direction. So you put it back into heating mode, the reversing goes back into heating mode, you turn off the auxiliary heat to temper the air, and then you switch back to closed so the fan can come back on.
I didn't know if it was normally closed or not when it comes to with the defrost.
Yep, normally closed and opens during defrost.
He's right.
Just throwing it out there. All right. Next. So any other questions on the outdoor fan motor, guys? No other questions on outdoor fan motor?
These are available, right?
They are available, and they are available at your favorite wholesaler. And if they do not have them at your favorite wholesaler, make them order them.
I wanted to make sure this wasn't like, oh, it'll be available in 3 months.
No, it's been out for 5 years on the remote, and 5 years on the remote mount-ish, 4 or 5 years on the remote mount. I've had one on my train package unit for 4 years, running up on the roof in Phoenix. It's a great product. Yep. The thing that your question there, they're available, cracks me up every single time I run across and present to technicians. I present this to technicians, and it's a no-brainer. It's a no-brainer because you've reduced your inventory, and you can charge a little more for the motor because now it's an ECM. And by the way, it's 80% efficient versus 60% efficient, so the homeowner gets a little bit of a savings. So you add all those things into it, and everybody goes, hey, where do I find them? Right? Where do I get them? And it's been out for 4 years, and the love has not been spread enough. Still at 80% efficient compared to the power that it's using, and if it's using the same amount of horsepower as it was before to drive that fan blade, it's going to be 20% more efficient because it's still driving the same horsepower.
So there's a little bit of payback there then.
Payback's a little rough. All right, I will say that it is 20% more efficient, but when you're talking about a motor that draws 1.7 amps, right, and you're shaving off 0.4 amps maybe, right, something like 0.3 amps on there, that doesn't show up on a utility bill. In a whole season, in Arizona, they might save $20, but I wouldn't sell it as they're save all this money on their utilities. But some people like to be green. Some people, just want to save some money, and it can add up. What you do in your selling process on how 80% relates, I would not tell them that they're going to see $100 savings in a year, right? Yes.
Ball bearings and all of them?
Yes.
Not bronze bushings?
Not bronze bushing, ball bearings. Yep.
What do you like the contractor cost?
Contact your local wholesaler. So the hard part with us, I work for the manufacturer. I don't know what your wholesaler or who you buy from, what's going to charge for it, what they're going to charge for it. I do not guess.
Did you pay for yours?
Since I work for the company, there was one donated to put it on my roof. So good stuff, good questions. I don't know the price. All right, secondly, other question I heard, excuse me? No? Okay. Next motor, and I might be running out a little bit of time here, but we'll push forward on this, is the indoor fan motor replacement. Oh,
Outdoor motor, are the wires, they don't have the connector like that, do they? It's just wires coming right out of the motor for weatherproof, right?
yes. More on the question. They come. Yeah, the wires come straight out of the back. No. There are. Sorry. Let's do what you're never supposed to do, is rewind a picture here. So out the side of the motor, you have this grommet right here, and then on the back side, you have a grommet coming out the back side over there. It's weatherproof, yeah. And so I've just broken all the presentation pieces here, but we're going to go back through the other way really fast. Back to IM. Yes, sir.
What's the part number on that OM motor?
6303R. And please do not yell a price out in the middle here. Thank you. All right. Second motor we want to talk about is the blower motor replacement. So a blower motor replacement we have is called Evergreen IM. Really fancy name, Evergreen indoor motor, right? Indoor motor. It is also designed to replace PSC. It's designed to replace PSC, and it comes in two sizes. Comes in a 1 horsepower that goes down to a half, and it comes in a 1/2 horsepower that goes down to a 1/4. Depending on your market, depending on what size you need, you select what you're going to keep on your truck. Some guys keep 2 on their truck, they keep a 1 horse, and they keep a 1/2. Most people on their truck, they keep the size that they normally use. Right, so if you run mainly 1/2 horsepower motors, I would stock the 1/2 horsepower motor on the truck. This motor actually is dual voltage, so it's 115 and 230. It is designed to replace a PSC motor, not designed to replace a constant torque or X13 motor. Okay, it's designed specifically for that. We call it our Evergreen motors. We call it ECM made easy. We design a motor to replace a application, not a Swiss Army knife. So if you're replacing a PSC, you should use an Evergreen IM. If you're replacing a variable speed motor, you should pick our variable speed replacement, not try to MacGyver it into what you're doing. All of our green motors come with 2-year warranty. There's no capacitor on this. The voltage selection is actually from a jumper. We actually take either a white jumper or a yellow jumper to select voltage. The yellow jumper is all plastic. So what does it do? Nothing. So the motor out of the box is 230 volts. If you use the white jumper and you're in a 115 volt market, that is how you convert it over to 115 volts. You should put that plug in first. That's the reason that's my first slide, is it has to go in first, because if you do not put that in first, you've got to take the plugs back out of the motor to get this plug in, and then go back in the opposite direction. Yes, sir.
So if there's no capacitors, since normally we're running on single phase here, how does it get going? Because normally a single phase motor needs a capacitor to get going, or something that gives it at least a second phase.
So there's no external capacitors. Internal to the module, there is a capacitor or capacitors inside of it. And the motor is actually a 3-phase motor. It's a 3-winding motor inside. And the capacitors inside the module, they have them inside versus external. So there is a capacitor, but there's not a capacitor that's external that you have to replace and or could fail. It's inside. All right, so wiring it up. If you have a standard PSC motor, and you have a standard PSC motor, most of us think about, when we have a standard PSC motor, most of us think only about 3 wires. We think about the white wire for neutral, or if it's 230, a yellow wire. You have a black wire for high speed, a red wire for low speed, and in most cases, that's all we think about, right? But we also have the capacitor wires when we talk about this that are going over here that we no longer have to hook up. And in most cases, you have at least one other speed, either a medium speed or a medium low speed that's inside the system. So what we're going to do to replace this is we're going to actually unwire the old PSC just so you can see how simple it is. And we're going to rewire the ECM back in its place. So we're going to add 1 extra wire compared to what we had before. Because you mentioned earlier, it's better to have the motor with line voltage going to it all the time. And in this case, we don't just have 1 contactor pulling in. that's going to turn it on and off. We have multiple things on here that can turn this motor on and off. So we want to have it ready to run by taking line voltage to the motor all the time. Okay? So we're going to install our line voltage wire. We are going to take off our neutral. We're going to install our neutral. And then we are going to take off the red and black wire. We're going to get rid of the PSC. And then we're going to install our red and black wire on the system. So right now, if you look at how this is wired up, the only thing that's different is what?
Constant power on the L1.
Constant power on the L1. So this is just mimicking what you saw before. Now we do have a change though. You notice this big chart sitting up here. This big chart sitting up here tells us that this red and this black wire are not for speeds. They're not for speeds. They're for selecting horsepower. And we're selecting horsepower off of these red and black wires. All right? So if a guy doesn't read the instruction manual, which happens somewhat, and all he does is wire it back exactly from what he saw, and in the back of his head goes, hey, I got to get power here, and he wires it up like this, it's going to come on and run once he wires up the low voltage side, right? But what we want to do is we want to make sure we match the horsepower that was there before, all right? So if you took out a half horsepower motor, or you took out a 3/4 horsepower motor, or you took out a 1 horsepower motor, we want to make sure that matches. So in order to make that match, we're going to do something scary for guys who replace PSC. We're going to put a jumper in here. And when we put a jumper in here, and we jumper between heat and cool, that means that if I call for heat or I call for cool, I'm going to run as the same thing. So in this case, when I have a red and black wire hooked up, when heat calls or cool calls, I send 120 volts back to that motor as a signal on the red wire and then on the black wire. And when I get 120 volts going back on both wires, and I get a signal on red and I get a signal on black, the motor knows to run as the highest horsepower. So if the motor I took out of the box was a 1 horse, it's going to run as a 1 horse. If I only wire up the black wire and I only get 120 volts back on black, it runs as the medium horsepower. So if the motor I took out of the box was a 1, it also runs in a 3/4 and it runs as a half. So in this case, it's going to run as a 3/4. If the motor I'm replacing was a half, I only hook up the red wire because it runs as the lowest horsepower, right? So if that makes sense, what would happen if I didn't put the jumper in?
Nothing.
It would run in 1 horsepower in cool and 1 horsepower in heat. So in this scenario, if I had a 1 horsepower motor that I installed, in heating it would run as a half horsepower. In cooling it would run as a 3/4 horsepower. But by putting the jumper in, it runs as the same horsepower all the time. Now if you're using the larger motor or the smaller motor, it works the same. The horsepower has changed. So if you use the half horsepower, both wires are a half. The black wire is a 1/3. The red wire is a 1/4, right? So in this case, we're gonna wire it up, and we're gonna say we're gonna run it. It's the 1 horsepower motor. We're gonna put it on the red wire, so it's gonna run as a half. The only thing I have left to do is actually hook up the speeds. And if I hook up the speeds, we do that with low voltage. It's a constant torque motor, right? So we're gonna hook up 24 volts to tell it how fast to run, and we're gonna hook up 3 wires. The 3 wires we're gonna hook up common. We're gonna hook up the white wire to heat, which is going to be low speed, and we're going to hook up the yellow wire to cool. So if you just kind of sit there and color match wires, you're going to get this thing to come on and run, if that makes sense. And by doing that, by hooking it up like this, you're using all the safeties that are inside that gas furnace, or all the safeties that are in that air handler to where it's going to work normally. I'm using a board here to explain it because that's the most common thing you guys see nowadays, but if you had a 60% efficient furnace from back in the day, and you had a dial, and you had something like that you're working on that should be replaced, you could actually still wire that in. You should wire that into this system and put an ECM in a 60% efficient furnace. It would be crazy. But you physically could do it because it's going to use exactly what's there. Yes, sir?
So I don't know if you're doing this in residential, but what happens if they have a VSD controlled motor inside of theirs?
A VFD, yeah. So an ECM is basically a VFD all put together in one. All right. So instead of having a controller that's added onto a three-phase motor, you have a three-phase motor and you have a control on it. So it's a residential VFD. Is that 100% correct? No, don't ask me anymore. But it is basically that concept that you're trying to accomplish, right? You're trying to accomplish energy savings, and we've prepackaged it for a residential technician, right? Okay, good. These motors, also once you have everything hooked up, they are going to turn on and they're going to figure out which way to run by themselves. We call it auto rotation sensing technology, or rotation sensing technology. When you apply power and you get a call for fan or cool or heat, it comes on and it spins in one direction and it checks its wattage. And then it stops. And then it spins in the other direction and checks its wattage and it stops. And whichever one was pulling more wattage, it runs in that direction the rest of its life. Okay? So the important thing, though, that when you do this is you let it run its auto-sensing rotation. You let it come on and spend the 30 seconds to figure out which direction to go in, and it'll end up going that direction in the rest of its life. What you don't want to do is see it start going the wrong direction and then take your finger off the door switch, right? And then pull it out and look for the reversing plugs and slide it back in. There's no reversing plugs. There's nothing to do there. You also don't want to bench test it. You want to actually have a load on it. So you install it in the system, put it inside the system, turn it on, let it spin for 30 seconds going one way or the other way, and it will run the right direction for the rest of its life if you just let it do its thing.
Y'all?
Y'all. I've been around Macy all week.
Enough said. You grew up near him.
I did.
You say y'all did?
I've been in the South for 30 years. Arizona is still the South, but not the deep South. So it pops out, Ed.
Use guys.
Use.
Rest of the day, use guys.
All right.
Outdoor motor too?
Outdoor motor is not auto sensing rotation. A blade going forward or backwards at the same pitch is basically the same wattage used. So you have to select it. On that last motor, you actually have, it's a three-phase connection between the module and the motor. You have a red wire, a black wire, and a blue wire. And since it's three-phase, how do you switch direction of any three-phase? Switch two legs. So you take blue to red, red to blue, it goes opposite direction. Good question. So if we go to the comparison between PSC and ECM, if you go to comparison between PSC and ECM, you know, in PSC nowadays, you do get multiple horsepowers, right? It does come out multi-horse. But one of the things in the business, when you buy a third horsepower, multi-horsepower motor for a condenser, and you apply that, in all reality, the motor is actually, if you buy a third that goes to a 6, it's a third, right? So when you're replacing a 6 horsepower on it, it's actually still running as a third. The only difference is you have a littler blade on it, and we allowed that motor to get hotter because it's not using it for rotation, and it's using it for heat, and it keeps on spinning, right? On the ECM, it's actually truly a multi-horsepower motor because it only applies the power it needs to run that blade or run that wheel, right? Dual voltage in PSC? No. ECM, yes. Multi-RPM? Yes, in ECM. Capacitor needed externally for a PSC, all right? Energy efficiency. ECM is 80% efficient. A PSC is only 30 to 60% efficient, depending on what you're running it like. Quieter operation on ECM and a better warranty on a ECM also. So in my book, the title bout, TKO, goes to ECM, all right, for replacements. I know if you guys are dorky like me, a 1980s kid where I played a heck of a lot of Mike Tyson's Punch-Out, I was usually this guy, not that guy. All right. Chris does a really good job at this, but kind of the follow-up for support. We have Regal makes ECM easy. We have training aids. We have the website, Motor Master University. You guys all scanned that QR code earlier to be able to get the motor minutes. So a lot of good information here. Our tech support hotline is sitting in the back of the room. You get a live person when you call in to get tech support. And I blather and talk really fast and drag on. So here's your chance to ask me some questions before we run out of time. Anything else, guys? Anything else? Nope? All right.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.